Welcome back to Track Talk. This is going to be a video in our ongoing series about the data available from 18xx.games. And specifically, we're going to be looking at some of the information regarding map development for games played on the website, specifically 1889, 1830, and 1846, since those are the games that we have the most data for. The initial motivation for this video and this project was the pretty common complaint amongst players in the community that the 1889 map is, quote unquote, always the same. I'm a big fan of 1889. It's one of my favorite 18xx games, and I'm not embarrassed to admit it. To me, I don't think the map is that much more stale than any other 18xx game without input variation. But I'm certainly in the minority. I see it all the time that people post that. So I figured we would look at the data and see who's right. Is the map in 1889 truly different than in other common 18xx titles or not? So with that said, let's jump into the data and I'll explain exactly what I did and what I think the conclusion is, which may be a little bit surprising. There are probably a lot of different ways that you could approach this problem, but the way that I decided to look at it from the first is to basically look at each hex that is laid by players and look at the end game state for all the games in the database, and look at which tile with what rotation is present on each hex. So for instance, here we have K8, and there may be an upgraded brown track here, or there may be a green track at the end of the game. Those would be two different game states. As opposed to I-18, there's a lot more variability in terms of which track could be laid on that hex. So any of those hexes would be categorized within a vector containing all of the hexes for the entire map, and then you would have one vector describing that specific game, and you can compare that against all the other games in the data set. So I went ahead and did that and calculated a few metrics to describe the distribution of maps seen in the 1889 data set. And I want to just go through that briefly, and then we can look at the other games, 1830 and 1846, to see how they compare and whether or not there's truly a difference between the games. So in the upper left, we have the map distances. I was describing to you the way we've kind of quantized the 1889 map. And basically what we've done is compared each map within the data set to every other map and determined how far apart they are by assigning a value to each hexagon location. And you can see that when you do this, you end up with a reasonably normal distribution. Well, I guess it's not exactly normal since the frequencies in the center are much higher than you would see in a normal distribution. But regardless, you have, a mounded distribution like this, and that's centered somewhere around, we'll call it 6.6 or so. The higher the distance, the more dissimilar different maps at the end of the game are. So if we look at the breadth of the distribution of this plot, as well as where it's centered, that will give us an idea in comparison to, for instance, 1830, if the game is more similar or dissimilar across this data set. I also looked at how variable the tiles placed on a given hex were, and we're using entropy, which is just a fancy term for, I guess, variability, to look at that. This is another way we could look at and see if the map on 1889 is any different than 1830. And then the bottom two plots are probably less useful for this purpose, but it's interesting to look at how the hexagon locations or map locations vary in terms of, are they laid very frequently? And if they are, do they always get the same tile, or are they a tile that tends to vary a lot within the game? So if we look at some of the interesting tiles here in the map, we can see that, for instance, C8 has a lot of variability and it's also very frequently placed. So if we look at what C8 is on the map, it is this tile here. So it's going to be placed in almost every game, but you can imagine the number of tiles that this can upgrade to is going to be quite high. You could have the map splitting with two gentle curves if you're trying to block someone. You could have a straight if you're trying to bypass Kubikawa, for instance. So that makes sense. And it's just kind of a sanity check that, yes, this would be a very common location, and there's a lot of options that could be laid there. We will contrast that with something that is laid less frequently. So let's say B9, and B9 is going to be nearby, but it's the high cost tile. So you got to pay $80, and that disincentivizes people from laying it. And also, it doesn't really get you anywhere important. So as a result, it makes perfect sense that this tile would be almost never laid. So that's just as a sanity check. And it probably doesn't help me compare the games 1889 and 1830, but it is interesting to pinpoint, hotspots on the map in these different titles. So now that we've explained the type of analysis that we performed, we can actually contrast the results of the analysis from 1889 to 1830 and see if there seems to be a meaningful difference in the variation of the maps. And when we do that, I think the most important comparison is going to be the upper left-hand map, the map distances. So if we look again at the center of the distribution for 1889, we can see it's centered somewhere around 6.5, 6.6, whereas the distance for 1830 is above 0.8. So there is a pretty big distance difference between the two games, meaning that 1830 maps seem to vary more broadly than the 1889 maps. And if we look at 1846, we will see something similar where 1846 is centered maybe around 0.8. So again, much higher variability in the maps than in 1889. So this was kind of a surprising result to me. I really didn't think that 1889 was going to truly be more similar or less diverse than these other games, but I think I've proven myself wrong. So I have to apologize to everyone I've ever argued with about this. That it seems like 1889's map is indeed a little more stereotyped than a lot of these other popular games. So that was stage one of this project, and it's probably the least useful. It was just mostly a sanity check to make sure that I had cleaned up the data properly and that everything made sense. But I wanted to take it a little bit further and look at the actual strategies and see if we can characterize strategies in these games based on how the map develops. And in order to do that, I turned to something called cluster analysis that I am excited about, but is proven very challenging. So I wanted to present some early data from that effort and see what the community thought and if they had any suggestions about how to take it further. In order to look at the cluster analysis, we went back to the vector of hex positions and tiles and rotations on each hex. And we basically looked at creating a vector that contained all that data and then performed a principal component analysis to see which aspects of that vector were most important, and then did the rest of the analysis using that subset of the vector. So you can see here for 1889 that we have a vector with 100 dimensions or whatever, but we only need about 25 of them to explain most of the variation that we're seeing in the data. So we can take that reduced data set to do further analysis. It's also interesting to note that we looked at the variation in the data set with a slightly different metric, this cosine similarities, and this confirmed my earlier testing that the 1889 map was a little less variable than the other maps that we've looked at. So that was just a nice confirmation of that. So anyway, once we've done the principal component analysis, we're able to use a variety of clustering algorithms to try and see if the games within the dataset fall into certain families or certain strategies. The tricky part about that problem is that you don't necessarily know how many clusters to expect the data to have, and you need to define that for these algorithms before you run them. So there's a couple of different techniques that you can find at Stack Exchange and various resources that were supposedly supposed to help you pick the number of clusters up front and then perform further analysis. The, I guess, oldest way is this quote unquote elbow method, where you're supposed to look at the point where the graph slope changes. So in this case, there isn't a very dramatic change, but maybe somewhere 3, 4, or 5 clusters would be a reasonable estimate. And then there are kind of more sophisticated algorithms that are supposed to help with this as well that I've looked at. And it seems like the data just is not particularly well suited to break into very distinct clusters. So I ended up settling on, I believe, about 4 clusters for 1889, and this will be different for each game. So I think 1830 was about 2 clusters, for instance. But you have to do this kind of analysis up front before you start running the actual algorithms. So once we did this, we can actually pick a number of clusters for the algorithm and then run it. And you'll see that on the right-hand side of the screen displayed graphically. So the first thing you do is just do a graph of the major components of the principal component analysis. Then you can do something called a UMAP. And when you have the UMAP, you can assign these points to a cluster with a specific clustering algorithm, in this case, HDB scan. There are a number of different algorithms that can be applied. They all have their own, use cases and pros and cons. For this type of data, it seems like the HDB scan algorithm is the most appropriate, but I have tried it with a number of different algorithms, including like k-means, which is another very commonly used algorithm. And basically what we're looking at here, I'm going to focus on the UMAP display, is different games and trying to divide them into families of games. So we have the light blue family, which would be cluster 2. We have the brown family, which would be cluster 1. Cluster 0, and then these red points are points or games that the algorithm thinks doesn't really fall into any family, and they're just considered noise. So you can see that the algorithm seems to think that in 1889 there are distinct map configurations within the data set, but when you just look at this as a human, it doesn't really convincingly break apart into different families. It's maybe just the algorithm kind of overcalling the differences. And we could plot this in 3 dimensions. Maybe there's a little more differentiation between these clusters in 3 dimensions. But in general, I wasn't very impressed by the clustering characteristics of the 1889 game group, which maybe just is further confirmation that the map in 1889 is not very variable and not a very useful way of looking at the strategies in that particular game. So we did this for 1830 and 1846 as well, and I think that data is actually a little more interesting to look at, so I want to show that to you very briefly before we go on. So this is the analogous data for 1830, and you can see in 1830 we've done the same type of approach, but the data is very different. Instead of just being a big blob, you can see that it has this kind of oblong distribution, and if you cross your eyes a little bit and use your imagination, you could hallucinate that there may be 2 distinct classes of games up here in the right-hand corner and then down here in the left-hand corner, separated by a less dense area of noise. So this is a little bit more useful in my mind than the 1889 data, and something that I was hoping to see, a real delineation between different types of games. The 1846 data is even more interesting, because when we look at that, you can see that the data is really divided into quite distinct groups. If we just look at the principal component analysis, there's this banded characteristic to the data, and then the algorithm tends to divide it into the 4 quadrants of this kind of rectangular orientation. So for 1846, the clustering algorithm is assigning 4 different types of games or families of games. Now, whether or not these families of games actually correspond with anything strategically is hard to answer. And that's kind of the next step of the analysis where I'd like to go with this, is to see, if we look at a game in the blue family versus a game in the pink family, can we see a big difference in how the map actually looks and what that might mean for how the players played the game and what strategies they pursued. So I've not done much clustering analysis. This is my kind of first time messing around with this stuff, but I was intrigued to see how different the data looks for the different types of games. So 1889, just kind of a homogeneous blob of data, whereas 1830 perhaps having a dichotomy of game types versus 1846 having a more distinct structure to the data. Definitely a work in progress, but I was interested to see this, and I think it's something that I will continue to refine over the next couple of months. But I did mention that I wanted to have a better way to visualize this data, and I've been working on that. It's in its infancy, but I just wanted to kind of give a teaser to where this is heading and what type of things we may be able to do with this in the near future. So I'm going to return to the 1830 data for the rest of this conversation. And what I did was that I tried to identify some features algorithmically that would distinguish, cluster 0 from cluster 1. Which tiles with which rotations are most characteristic of these clusters, and whether or not we could plot that in a way that would be familiar to 18xx players. And to that end, this is what I've kind of come up with. So the graph on the left is my kind of hacky way of looking at the 1830 map for one of the clusters, and the map on the right is the second cluster that we've identified. You'll notice that these graphs don't include any of the pre-placed tiles, and that's why they kind of look differently than what you'd be used to looking at on 18xx.games. These only include player-placed tiles, because those are what we're interested in for the sake of our analysis. And you can see that just by looking at these graphs, they look very different. So the graph on the left is a very kind of undeveloped game state. Not a lot of tiles have been placed versus the graph on the right, where the map is just much more congested. Both of the maps have obviously made it to the brown phase, so they're both late game maps. But for some reason, players on the left-hand side were unable to place as many tiles. So whether or not this game ended quickly compared to the game on the right, I can't say for certain because I haven't really done a deep dive into that. But there's clearly a real difference between the types of games that end up in these clusters. And what I tried to do, you can see on the map on the right, was have the algorithm actually plot which tiles it was identifying as being the most characteristic of the games in this cluster. So, for instance, we have D18 highlighted here in a red outline. The cluster has identified this tile with this, or I should say this hexagon, as being a more important hexagon for games in this cluster compared to games not in this cluster. And I've used a couple of different parameters to define these tiles. The visualization is in its infancy. I'd really like to clean this up so that the transparency or opacity of these tiles varies with importance as well. And I just haven't gotten that quite working yet. I think there's a couple of problems with this approach that may be limiting the utility here. And I'm actually going to totally change my approach to this type of analysis in the near future to try and get better results. So instead of just looking at the tile and the rotation on each hexagon, I'm actually going to create a connectivity matrix where we look at how each hexagonal location relates to its surroundings. I think this is the implementation for the actual engine on 18xx.games that's used for instance, the auto router. But it's just a different approach to what I've been doing currently. So it's going to take me a little bit of time to get there, but I think it will give us more robust results and maybe more meaningful clusters. So hopefully we can get that implemented soon and actually take this to the next level. Another shortcoming that I've been kind of bouncing around in my head is that perhaps we shouldn't be just looking at the end game maps, because you can imagine if a game goes late enough, people are no longer really making meaningful track decisions in a lot of games. They're just laying random tracks, or they're just passing because they don't have track valid track options anymore. So maybe it would be more useful to look at an earlier stage of the game, perhaps when the first D train is bought, or maybe right after the fives come out, to really see the diversity of the strategies. I just worry that if we are looking at a lot of games that go, 11 operating rounds or something like that, we may just see a lot of noise and just a lot of people kind of twiddling their thumbs, so to speak, and laying random track that's not, strategically meaningful. So those are two things that I've been kind of thinking about in terms of this analysis as next steps. So I guess in summary, I would say that this analysis has been kind of a mixed bag. I was able to convince myself that 1889 is a little bit less variable than these other games. But when I tried to take it to the next level and really start diving into the strategic implications of the map development, I haven't really been able to make any strong conclusions. But I'm going to keep working on it and hopefully have something to show for it in the near future. So I realized this was kind of a nerdy video and really got into the weeds with some things, but hopefully people will find it useful to think about this. And I think that with continued effort, we'll really be able to use this data to learn how to play 18xx better. At least that's my goal. So anyway, thanks for watching. We'll be back in the future with more of these types of videos.